Welcome to the Health Fix podcast, where health junkies get their weekly fix of tips, tools, and techniques to have limitless energy, sharp minds, and fit physiques for life. One of the best things you can do to improve your health is get at least 7 hours of quality sleep every single night. I know, it's hard to get that much sleep. Your mind keeps you awake, you're thinking about things, you get uncomfortable, you wake up early, and you just can't fall asleep again. There are hundreds of reasons why you can't get 7 hours of quality sleep every single night, and I've probably at least told you 100. But hey, listen, it's super important because your body heals itself when you sleep. And if you're not getting enough quality sleep, you're increasing your risk of disease and making it harder to lose weight. Yes. Wait, would you like to know an easy way to get more quality sleep every night? Make sure you're getting enough magnesium. Believe it or not, around 75% of people don't have enough of it, which helps explain why so many people have sleep problems. Unfortunately, most magnesium supplements are not full spectrum, so they won't fix your magnesium deficiency or help you sleep better. There are actually 7 unique forms of magnesium, and you must get all of them if you want to experience its calming, sleep-enhancing effects. That's why I recommend Magnesium Breakthrough by Bioptimizers. Simply take 2 capsules before you go to bed, and you will be amazed by how much better you sleep and how much more rested you feel when you wake up. For an exclusive offer for my listeners of the Health Fix podcast, you guys want to go over to www.magbreakthrough.com/healthfix. And you can save up to 42%. Yes, that's right, 42% savings on Magnesium Breakthrough when you go to www.magbreakthrough.com/healthfix. Hey Health Junkies, on this episode of the Health Fix podcast, I'm interviewing Hannah Wendt, one of the founders of TruDiagnostic. This is a company that can tell you how fast or how slow you are aging, and they do it via your DNA, but in particular, they're not looking at the SNPs, something that you would normally find in the 23andMe type of testing. They're looking at methylation, which means they're looking at what genes can be turned on and off in any given sequence. So what's happening to make you older? What's happening to make you younger? I did their testing about probably 3 months ago and found out that I was 7 years younger than I currently am, which had me feeling wonderful. But then Hannah tells me that there are folks who are 10 to 14 years younger. And so now I'm like, yep, I'm gonna go for 15, and I say it at the end of the podcast. So you guys gotta hold me to it. My next testing, I'm shooting for that. But what's also cool about TruDiagnostic is they also are coming up with midway testing, meaning you can retest every 6 to 8 weeks to see, are you making progress towards your goal to improve how well you're aging, which is pretty impressive if you ask me. So nevertheless, let's get into geeking out with Hannah Wendt and talking about TruDiagnostic. Hey, Health Junkies, I have Hannah from TruDiagnostic on today with me. I've got the box here if you're watching live. I did the testing not too long ago, found out that I was 7 years younger than I currently am, and was super jazzed about that. But I wanted to be more like 15 years younger. So I decided that there's probably more folks out there that want to know that too. So I brought Hannah Wendt on so we could talk all about TruDiagnostic, what it is, and why you want to know about it. So Hannah, welcome to the Health Fix podcast.
Yeah, thank you so much, Dr. Krause, for having me. I'm excited to be on here and speak a little bit more about our company.
So a lot of people are probably looking at the two of us right now and going, why do these two even care about aging? They look young. Like, what is the deal here? Well, folks, it's one of those things that you got to be thinking proactively. Mm-hmm. And so obviously, Hannah, you're working with TruDiagnostic. I love stories. And you're young, but what got you interested in working with a company like TruDiagnostic to work on figuring out how well or not well someone is aging?
Yeah, absolutely. I have an interesting background and a little bit of an interesting path. So I've always had, a passion for longevity and different breakthrough disruptive technologies that improve the human condition. So just, lifespan in general, like you talked about the aging, but more health span. So I don't want to be 80 years old and not be able to walk to my mailbox, right? You want to increase that health span as well. So I'm, traditionally trained in biology. I went to University of Kentucky and had some research internships with cell signaling and cell biology. But after graduation, I worked for the International Peptide Society. I was their director of research and content. So I had a special niche, so to speak. So through that work, that's where I really got my toes in the door for being in that integrative medical industry. But a couple years later, I was interested in the methylation-based age diagnostics and the epigenetic biological age testing, and me and a couple others just started TruDiagnostic in 2020. And originally didn't want to open up a lab. We would have rather took the easy way out and partner with someone, but couldn't really find a great partner. So we said, why don't we just open our lab? It was really, really crazy. So I've been with, TruDiagnostic from the start. We're about 2 years old in July this month. So it's definitely been a crazy whirlwind journey, but excited with what we've done so far.
That's awesome. Well, this is fun because I didn't know that about you. We've been talking about the TruDiagnostic testing for a while now, but I didn't know that you were actually one of the founding members, if you will, and creators. So that's really neat.
Yeah, absolutely. We've had a lot of accomplishments. We've tested about 15,000 different patients to date. So we have one of the world's largest private epigenetic databases. Like you said, we're partnering with healthcare providers like yourself to see what actually moves these metrics, what maybe makes you a lot younger, hopefully, but we maybe see some results that we wouldn't have thought of that make you maybe age a little bit. So we have about 30 clinical trials as well, but love to work with, people like yourself, just because you're testing patients, you're looking at the data and a lot of other different multi-omic variables too. So you make for the perfect, customer and helping us solve this aging solution.
Yeah. No, I mean, with aging, I think a lot of people are like, really? They've heard the DNA stuff. There's multiple different companies out there. And of course, we're going to talk about what sets you guys apart. But in particular, a lot of people are like, I really can tell how old, how I'm aging, like this whole process. Would you tell folks a little bit about how the testing, like, let's go with like, what are we testing, and how does it give us some info so that folks have a background there?
No, that's a good question. It's hard to almost talk about this subject because there's so many different interconnected pieces. So, everyone has a gauge for chronological age, but there's this new biological age that we can test the age of your cells, how your body is functioning. So what we're really looking at is these epigenetic markers. So epi, the way I describe it to people, means above this genetic baseline sequence. So we're not testing your SNPs like if you were to go to 23andMe or any other type of genetic-based testing company. Those are your variants. Those never change. I think it's a little bit sad where you have the variants from your parents, but you can't do much to change it unless you get into some gene editing, which is still far ways away. But we're looking at those markers on top of the DNA that actually are changeable. So it's called methylation, where we're just looking at if there's a methyl group attached to that genetic sequence. And all the epigenetics in the DNA methylation, all that means is how are your genes being expressed? It's like if they're turned on or if they're turned off, and how much are they turned on and how much are they turned off?
Wow. So I think a lot of people do look at the 23andMe and go, okay, what am I going to change from this, or how am I going to do things better? And that's interesting that you mentioned that you can't change it, because that's a very good point for folks to see. Whereas you guys are looking at the genetics you can manipulate, the ones you can monitor, the ones you can, move forward to. And I think a lot of people may have heard of methylation, but are like, what in the world is it? Would you give us a brief, like however many seconds, description of why we care about methylation and what it does for us specifically in the body?
Yeah. So when we talk about methylation, a lot of people who are very familiar in the healthcare space think of your MTHFR gene, right? Yep. Keep in mind, we're not testing any genes, not testing any SNPs. So a lot of people, though, because of that, think methylation is bad, and we don't want any methylation at all. But that's not true. With this methylation-based testing that we're doing, again, we're just looking at a percentage of methylation on about 900,000 different locations. So how much is it methylated? So how much is it turned off, or how much is it turned on? Because all DNA methylation means is that it is silenced. If something's methylated, the gene is silenced. You're not getting that transcription. You're not getting, the protein folding, and you're not getting the phenotypic outcome. So, in our case, methylation is not good or bad. It really depends on the location that you want to look at. So an example I love to use is, you want to methylate, you want to turn off your oncogenes or your cancer genes, right? You don't want those to be expressed. Whereas you want to not methylate your tumor suppressor genes. You want those to be turned on, right? So you do not want to methylate those. That's a really nice example, because then people are starting to understand, okay, I want to regulate my overall methylation. I want things to be turned on, and I want things to be turned off. So once we talk to them about that message, it becomes a lot more clear, the difference between that genetics and that epigenetics.
Oh, I'm going to steal that, because that,
please do.
I mean, that just lays it down better, because a lot of people, when I've described, they're looking at methylation process, they're like, well, I have my, MTHFR sequenced. I know that I have a 677 mutation or whatever, it may be. And I'm like, it's not really that. And when she's talking about the different locations, guys, we're talking about locations on genes, not the actual, like the SNPs. And this is what you would see in terms of the data that comes out from things like 23andMe, or if you've had your mutations looked for, say you had genetic testing or something to see if you've got cancer genes or whatnot going on.
Yeah, absolutely. There are some studies out there, and these will become more apparent as the research goes on. There are some studies out there relating genetics to increases or maybe decreases in biological aging. So for example, there's a study that looks at the MTHFR gene. And if you're a woman and you have this 677cc variant, you may have some advanced biological aging. So there are certain genes that can affect your methylation and your epigenetics. So they do go hand in hand, but two separate processes. Yeah.
So we're strictly looking at, are these things turned on? Are they turned off? And in certain cases, that's what's going to predict how fast we are aging in any sequence of time.
Yeah. After, taking it a step further, after we have those 900,000 methylation markers, we would never just give you that raw data. I don't think anyone in the world can interpret that raw data.
Time to look at.
Yeah, it's massive amount. I don't even know if I could download the files on my laptop, but we do all of that for you, right? We're taking our epigenetic clocks and those algorithms using artificial intelligence, different machine learning models, and we're interpreting specific markers then to give you what we're looking or what the focused outcome is, whether that is your overall biological age, what we call your intrinsic epigenetic age, the age of your immune system, what we call your extrinsic epigenetic age, your immune cell subsets, your pace of aging, the list goes on and on. Even we measure other things that aren't necessarily related to aging. So methylation is just a really great biomarker and predictor of itself.
Wow. Did you learn this in school, or did you guys have to come up with this? Because I'm like, I didn't learn that. I mean, granted, I've been out of school for 15 plus years now, but I'm like, wow. Did anyone talk about this in school, or did you guys like go out on your own and go, we're trying to find, what we can test. This is something that you found.
Yeah, I get that question a lot, actually. And it's interesting because then I'll ask the person if they had any training. And I maybe remember, 15 minutes maybe being touched on epigenetics. I even know people in med school who said, yeah, we had an hour lecture maybe. All I remember them teaching me is that the promoter region is in control of your expression of your genes. And that's because the methylation markers are in the promoter region, right? So that is like the only thing I can comprehend from school. But yeah, it's, we're all really trained from the ground up at TruDiagnostic. So it's still really, really new, and we're learning as we go, which is great as more research comes out.
Wow. So I think at this point, what comes to mind for me is like, okay, so what do these machines look like that, guys, so it's a finger poke test. We're taking blood and so the blood goes, actually, here's the fun part about it, because side note, when I was poking my finger to get the blood out, I was like, I've done this before. Why can't, so there's a little tube, guys, you fill with blood. And I was like struggling, and I'm like, what is it? How is this gonna, like, what is going, how are they gonna get this in the machine? So I don't know if I'm jumping ahead, but we'll roll with it. When you guys get the blood to put into the machines, like, what does the machine look like? How does it go from tube to to results?
That's a great question. And I don't know if I've told you this, Dr. Krause, we actually just switched to a blood spot card. So I think you had the older EDTA
tube. Yeah. I was like,
it was a lot harder. So we just validated the blood spot cards in our labs. It took us forever. It's finally there. So it's a lot easier now. So any new kits you order will have that blood spot card, but
don't worry, folks. If you're afraid of blood, I know as I said it, I was like, I'm probably going to scare some people here. So awesome that there's blood, the spot cards, because those are way easier.
Yeah, absolutely. The laboratory process is probably not too foreign to a lot of people listening. We take your blood sample, we check it in through our LIMS system. It's, short for laboratory information management system. So proprietary, where, we connect your barcode with our system. We're blinded to whose sample it is. We do the extraction and then the quantification. And then we actually do this really specific process, which is unique to methylation markers, called bisulfate conversion. It's, basically where we're highlighting the methylated positions and what we need to take to move to the next step. Bisulfite conversion is a really, really harsh process. So it basically denatures the DNA, and you can't ever change it back to the original DNA sequence. If anyone's worried about privacy, right, where we're basically smashing up your DNA and it can never be tracked back to you. From there, that is called the pre-amplification area. Post-amplification area, we're actually going to send it into an Illumina infrastructure technology. So that's where all the big machines come into play, where we have a couple TCANs and they do, automatic processing, where they're adding a lot of solutions to your sample. It will then go in what we call an iScan from Illumina. And the iScan is the big money maker. That's where it's actually scanning your sample through and looking at those methylation intensities, producing that raw file.
Wow. That's cool. Thanks for sharing that, because I think a lot of people, yes, we kind of have the idea of the labs, but the sequencing component and scanning in particular is what I find fascinating. Gas spectrometry is something that we used in chemistry when I was in school. And I absolutely loved when you put the little drop of the thing in there, and then we get all these waves to tell, what is in that particular drop of whatever. And so, this is much more advanced than that, folks, if you've ever seen a gas spec machine. But this is cool in terms of being able to have this much information about yourself.
Absolutely. I don't think you appreciate it enough until you see the sample, and all, our lab technicians, who we're very thankful for, and our lab director, go through the entire process. It takes an actual physical week for that entire process to happen. So from the time we receive our sample to the end, we cannot do it in shorter than 5 days. So it's I guess normal time process, but still can be a little lengthy when we're receiving your sample. There's other samples in the queue. So you usually get results in about 2 to 3 weeks after we receive the sample.
Wow. Well, you have to, right? Once you get the results, now we have to put them into something that's something that you can actually read and digest, and not be like, I have no idea.
Correct. The data processing side, where you're taking the raw data file and then putting it into the algorithms and then giving the reports out. So you're right. There's a little, time before on receival, and then time after when we're actually giving you those results. But yeah, all the results are super patient friendly. They're on quote unquote layman's terms, but obviously if you're more scientific driven, probably like most of you listening, you'll definitely understand the reports. They're really good to read.
Yeah, there's a lot. My download, I was surprised how many pages. It was a small novel, but it was good, because it gave me really, I'm a geek. And so I love looking at the information there. So now people might be thinking, okay, algorithms, where do you get the algorithms from? The AI kind of side of it, the artificial intelligence kind of side of it. Where does that come from? How do you integrate it into the system that you have to create the results?
Yeah, it's that's a really good question. To back up a little bit and talk about maybe why TruDiagnostic is unique in the epigenetic methylation space. We would only ever use published, validated algorithms, period. We'll always be transparent with you on that, because it's important that what we're running your sample and your data through. That way you can apply it to any literature that is published in the future. So again, you can look at your data that maybe you tested 2 years ago longitudinally, if another research paper comes out, you can apply it to that data set. So we will only ever use any published validated algorithms. For example, one of the algorithms that we have called Dunedin PACE, it stands for your pace of aging. So it's a instantaneous rate. It's how are you currently aging biologically for every one chronological year. We exclusively license that one from Duke and Columbia University, and with the help of University of Otago out of New Zealand. So that's a really great example of where we get our algorithms from. And then that also allows us to make really great connections with their research teams as well. We, of course, have a lot of in-house biostatisticians and bioinformaticists, but when you actually start to, work with some of the experts that have these studies already built, it helps open your eyes to all the other opportunities, right? It's like when you start a study and you think your hypotheses and your question is one thing, and then you're, 6 months into it and you're asking all these other questions because these other results came up. So it's the more you know, the more questions you have.
Yeah, no, it's true. It's true. And I think, for DNA, I mean, we're right. I think we're at the beginning of things in terms of what we can learn and what we can do with it, more than just looking at something and, oh, I have this, oh, I don't. I'm more interested in, okay, what can I manipulate? What can I fix, improve, and optimize? That's what I want to know. And I'm guessing that most people, versus just random information, that's what they want. And really looking at the different companies that are out there for DNA testing, it seems that majority of what is available to the commercial, industry where folks can order things without a practitioner, it does seem that it is just straight DNA information and that's it. So you mentioned one thing that sets you guys apart. What are a couple other things that set you guys apart from some of the other DNA, sequencing companies out there?
Yeah, absolutely. Love that question. So I mentioned, we only use published validated algorithms.
Yep.
Number two, this goes in hand with number one, but we use blood as a collection specimen, which I know Dr. Krause mentioned, if anyone's scared of blood, buyer beware. Unfortunately, saliva and urine have not been successfully used in creation of any of those publicly published validated algorithms. So we will only ever use blood as a sample type, which again, some people may see as a con rather than a pro, but that is to give you the utmost accurate, precise, sensitive and information possible. So those two go hand in hand. I think another great point is that we are built for healthcare providers. If any of you are health providers listening or health coaches, the reason that is so important is we need people to help us interpret these metrics with their patients, right? We offer you education, we offer you new reports, we offer you, supports, different educational information sessions, even just like this podcast right now. So we really like to work with healthcare providers because we can actually give them more access to reports. We can give them some disease-based reports. We have a diabetes risk report, a obesity risk report, a mitotic clock report that goes over your cellular replication levels. So if you're a consumer, you should definitely get the test through a healthcare provider, because again, once you take it, they're going to give you a protocol or a plan to help you reverse those markers and to help you slow down your aging. So we're built for both, but I would say our healthcare provider platform is really great. And a couple other things, we're always on the forefront of cutting edge. We have about 30 clinical trials going on, looking at what actually changes this metric. We gather a lot of covariate data as well from those healthcare providers to make new algorithms and to keep you up to date with a lot of those new reports too.
Yeah, that's what I like about you guys. I mean, for those of you listening that are providers, or even just for you guys who are wondering, how much how much education do we get around these test results and how to interpret and how to provide protocols that work? These guys actually will, they do trainings. I've seen every month that there's a training, but there's also, a great deal of protocol suggestions too. So, and things that work. So folks, we're also well supported on that back end of things too, which is why it's good to work with someone who is a practitioner who's been trained by TruDiagnostic to know how to take the information and get the most out of it for clients. And backing up the blood thing, for those of you who are afraid of blood, it's not that bad. It's only because the tube thing earlier, it was a little tricky, but blood spot stuff hands down so much easier than a blood draw. So yes, definitely looking at that. Now at this point, a lot of people might be going, okay, we've got a lot of backed up information, we've got a lot of that going on. Accuracy level, what is it, where's it at, and how does it compare into things that you can compare it to, I guess.
Absolutely. So this gets a little bit technical here, but again, a question you must ask to anyone who are doing these types of tests, right? There is a value called an ICC correlation value. And in our world, that is basically, if you take two samples at the same time and you run them in the same exact process, how correlated are they to one another? So that's the definition of this ICC value, intra-class correlation value. With a lot of the algorithms, they have an ICC value of about 0.6, which isn't great. Those are a lot of the old algorithms. We recently just did an update to our algorithms with what we call these principal component analyses algorithms, which is a really fancy way to say we add more QA, QC layers to make the samples much more precise in between sample times. Mm-hmm. So that actually raised that ICC value from 0.6 to 0.9. Which is considered really good. And I know I mentioned the Denington Pace algorithm earlier as well. That ICC value is actually at 0.92. So when people ask about accuracy, we usually change the conversation a little bit more to the ICC value. So they're only going to get more accurate, precise, and sensitive as time goes on, and we're testing more people, longitudinally, because that's what really matters as well. You can get your baseline and that's good, but we need to see how you're making changes, from a personal level, and then for those kind of metric-based levels as well.
Makes sense. On average right now, how many tests have you guys run throughout the course of your existence at this point?
Yeah, so about 15,000. And this month is our 2-year anniversary. So we ran our first sample in July of 2020. So we've run a lot of samples, and that doesn't even count all of our research-based samples too. So that's something that's unique about us, is that we do a lot of research with universities or academia-based partners who don't even have this technology out there at their schools yet, because it's so new. So we do a lot of custom projects for some clientele.
Very cool. Very cool. So we've talked all the geeky stuff. Now, folks, I think probably folks who've listened this far were like, all right, so what do I get with the TruDiagnostic test? What can I learn about myself, beyond how fast or slow I am aging? What other things can I look at in terms of preventative health or optimizing health, things of that nature?
Yeah. So remember, for those of you listening, people are coming to us because they want to optimize their aging process. That is why they've heard about us. That is what we specialize in. People who are coming to us are probably already pretty healthy, and again, want to be as healthy as possible to increase the lifespan and health span of themselves or their family or people who they care about. Secondarily to that, we talked about earlier how methylation is just a great biomarker in general. So there are some additional reports that you can receive that are a little bit more fun, I guess. We talked about the intrinsic, the extrinsic, the immune cell subsets, and the Denington Pace. Most of you have probably heard of telomere length. We do offer a telomere length interpretation-based test on methylation. So anything we're testing, again, based on methylation, and that means it's changeable. Telomeres used to be that sexy test for biological aging. Since then, epigenetic clocks have replaced that. It's still an important process of aging, but just plays a really, really small role as an aging biomarker. Some other reports that we give are going to be things like, how much have you smoked or drank across your entire lifetime? Are you able to lose weight in response to caloric restriction? So that can be helpful if someone's, looking to lose a little bit of weight, if that's their goal. And then, I mentioned some of those disease-based reports, the diabetes, the obesity, and the mitotic clock. But in the future, we'll actually be able to predict things like, inflammatory markers and different immune response levels, things like your IL-6 and your CRP, even hopefully hormone levels in the future as well. So those last things I mentioned are definitely upcoming, but that is why there's so much potential. Experts actually say this methylation testing will overtake conventional blood testing. They say 7-10 years. I say a little bit more. It takes, the science field moves relatively slow. So probably, 15 to 20.
That's fascinating. Well, and here's the thing, we're looking at cholesterol levels. We're looking at all of these different variables that can vary based on any given day. Whereas, I think with a lot of it too, we're looking at parameters that are a little outdated too on our lab values.
Yeah. Yeah, definitely. I think methylation will be I don't think you can get away from it if you're a healthcare provider, right? I think it'll be the next big thing. It seems so foreign when we sequenced the human genome and had the Human Genome Project, right? It was from a scientific field perspective, it was like, are we really doing this? And then it happened overnight, it seemed. And that's the same thing that's going to happen with methylation. We're where genomics was 30 years ago. But this is moving even faster since we have all this innovative technology and all these resources and data and partnerships. So my goal, what I want to see in my lifetime, is basically a map of the methylome. We only test about 900,000 methylation markers, and there's 28 million in every single cell type. I don't know if we'll ever be able to measure all of them, but for the ones that we can measure, it would be my goal to almost have like a map and say, what do you want your methylation to be at this position, and how do you get there? Yeah. And then, depending on other multi-omics, like your proteomics, your metabolomics, your genetics, that there'll be different ways to achieve those goals.
Oh, so cool. I'm hoping the hormones and the, what was the other one now? See, I need to work on my hormones. Maybe I need more of my power drink here. I want to know when that's coming out. I need to be the first to know about that. So I'm hoping maybe within a year or two on hormones.
Yeah, absolutely. Yeah, I definitely think so. With all these clinical trials going on and all the data that we're gathering, as long as we have the data behind it, we can predict really anything.
Mm-hmm. Nice. Notice, guys, as long as she has the data behind it. So we have the, it's one thing about, COVID and all this, it's all this data. But the bottom line is, I've always been a data geek. We have to have that proven process before we move forward. And definitely that's why when, I started hearing about you guys, I was like, oh yes, sign me up. I want to know about this. So one of the things that I wanted to ask you before we start wrapping up the podcast is, with looking at the average individuals that do the testing, folks might be thinking right now, like, okay, how frequent might I need to test or things? Because a lot of docs will be like, all right, for your cholesterol markers and inflammatory markers, that was the other one I really want to know too about, because inflammation is kind of like the feel for all kinds of imbalances in the body. But I digress. Sorry, guys. I'll a little bit today. With TruDiagnostic, is it common for folks to retest in 6 months, a year? What seems to be the sweet spot for a lot of people?
Yeah, that's a great question. So for this overall package that we offer, which it's called our TruAge Complete Collection, that offers everything and new reports even every 4 to 5 weeks. That one is going to be retested probably every 12 to 24 months. So every year, every 2 years. And I say that because we're actually coming out with a new product called the TruAge PACE, which is just the Dunedin PACE report and the telomere length report. You can measure that every 8 to 12 weeks. So the Dunedin PACE, you can do much more frequently, and it's going to be cheaper as well, right? So you can actually test that much more sooner, but then you probably do want the overall picture every couple of years or so, just to make sure you're still good in terms of your overall aging.
That's awesome. I love that. When I saw that come out, I was like, this is perfect, because a lot of times, waiting a whole year to know, are you making progress? Are you doing, are you on the right path, can be, it's time, right? It's like, oh my God, did I waste a year just trying to do the wrong things, Right. So having that in between is huge.
Yeah, absolutely. So we're excited about that product. We think it'll be a lot more feasible. So people can actually take a baseline, they can add or subtract something to their overall regimen, and then 8 weeks later, they take it again. And with a very, very high level of confidence, they can say that the change they saw in the Dunedin results was due to the change they made in the intervention. So that's where you get the real N of 1 true preventative based medicine, because you and I could both be taking metformin, for example, but I could have accelerated aging, you could have deaccelerated aging. The interventional trials are nice because you still know, but it's based on a population, essentially. You wouldn't know what works for yourself.
Yeah. Yeah. It's kind of a great way to biohack a little bit.
Yeah, it is an objective biomarker to quantify those changes you're making.
Yeah. Oh, that's awesome. So is that available right now, just to clarify for folks?
Pre-sale, pre-launch will go live Thursday, actually. So yeah, we have a webinar. If anyone just signs up for the webinar, you don't have to attend, but if you register, you'll get that pre-sale, pre-launch information.
Okay. Awesome. I think folks have got a ton of information now to kind of mull over on TruDiagnostic. And folks, I'm holding up the box again here. And literally TruDiagnostic.com, if they, and that's where you can find them. And what about now you guys are on Instagram, other places to find you guys. Give us the scoop on, and if someone's like, wow, I really like this, I want to jump in, I want to find a provider in my area. Give us the breaking.
Absolutely. You're right. TruDiagnostic.com. We're on Facebook, Twitter, LinkedIn is super helpful. LinkedIn, we actually post a lot of our studies and more of that, high level complex science information. So definitely recommend LinkedIn if you're on there. Feel free to reach out to me or our support team. So my name is again, Hannah, HANNAH at TruDiagnostic.com or support@TruDiagnostic.com. We can find a healthcare provider in your area if you're wanting to take the test as well, or just answer any questions you may have.
Awesome. My goodness. Thank you so much, Hannah, for giving us I think folks might have to listen to this one twice so that they get all of the info. Okay, really quick. I know I'm trying to sign this off, but I got to know what was as of what you know right now, who has the record for, obviously you don't know the person, but what's the number of years younger that you know of at this point?
Overall biological ages, probably anywhere from 10 to 14 years younger. Yeah, somewhere in that range. So it is possible. It's definitely possible.
That's it. I'm going for 15. I'm going to be your guys' record. That's what's happening.
I'm rooting for you.
Right. Good deal. Well, thank you so much, Hannah, for coming on.
Dr. Krause.
I look forward to chatting with you here in the future because I bet you guys have even more things coming down the pipeline. So we got to share that for folks.
Sounds great. Have a great day. Thanks for having me on.
My pleasure.
Hey, fellow health junkie, thanks for listening to the Health Fix podcast. If you enjoyed tuning in, please help support me to get the word out about the podcast. Subscribe, rate, and review, and just get that word out. Thanks again for listening.